Good day, students. Welcome to today's lesson on the mathematics series. I'm Emmanuel Kenneth. In our previous lesson, we talked about indices and we highlighted the laws of indices. So today, we're going to look at the binary system. I hope you have your writing materials ready. So let's get started. Let's look at conversion of numbers from order base to base 10. So in binary, it's usually in base 2. So we have 1 0 1 1 here. Since it's binary, it's in base 2. So for us to convert it to base 10 now, we have the first one times 2, which is the base, plus 0 times 2, plus 1 times 2, plus 1 times 2. So we start here 0 1 2 on the base. Please take note. 0 1 2 3. So in base 5 again, we have 423 in base 5. In base 10, we pick 4 multiplied by 5, which is the base, plus 2 times 5 plus 3 times 5. So let's look at the third one again. 5007 base 8. Now once take this to base 10, we'll say this is 5 times 8, which is the base, plus 6 times 8 plus 0 times 8 plus 7 times 8. So we have 0 1 2 3. So 5607 in base 8 is equals to 5 times the base, which is 8, plus 6 times the base, 0 times 8 plus 7 times 8. Now we're raising this to power 0 as a base. 8 is to power 0, then 8 to power 1, 8 to power 2 to power 3, like that. So let's look at these examples quickly. We need to convert the following binary to base 10. So let's take note of this, that in binary, it means what? It is in base 2. Base 2, but it's usually not written. So let me help you to put it like this. So 1, we have 1 1 1 1. It's binary, which is in base 2. So we want to convert it to base 10. So this is equals to 1 times the base, which is 2, plus 1 times 2, plus 1 times 2, plus 1 times 2. So we have 0 here, 2 to power 0, we have 1, 2, and 3, which is equals to we have 2 to power 3, we have 8, plus 2 to power 2, which is 4, plus 2 to power 1, which is 2, plus 2 to power 0 is 1, and 1 times 1 of course is 1, so we have 1 here. So this is equals to 8 plus 4 is 12, plus 2, 14 plus 1 is 15. So this is 15 to base 10. So 1 1 1 1 1, which is in binary or in base 2, is equals to 15 to base 10. So let's look at the second example quickly. Second example, we have 1 1 1 0 0 1 in binary, which is in base 2, is equals to 1 times 2 plus 1 times 2 plus 1 times 2 plus 0 times 2 plus 0 times 2 plus 1 times 2. So on the power of the base we have 0 1 2 3 4 5. So we have 2 to the power 0, 2 to the power 1, 2 to the power 2, 2 to the power 3, 2 to the power 4, and 2 to the power 5. Now this is equals to 2 to the power 5, that is 2 times 2 times 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, times 2 is 64. So we have so 2 to the power 5 is 32 plus 2 to the power 4, we have 16, plus 2 to the power 3 is 8, plus already when 0 is multiplies any number gives 0. So we have 0 here, 0 here, and we have 2 to the power 0 is 1 times 1. We have 1. This is equals to, so we have 32 here, 32 plus 16, we have 48. Now 48 plus 9, 17 here, so we have 57. So we have 57. So 111001 in binary is equals to 57 in base 10. So let's quickly look at conversion of numbers from one base to another. So we have 1101 in binary or in base 2 to base 5. Now take note of this. Now for us to convert from base 2 to base 5, first thing we need to do is to convert to base 10 first before we take it to base 5. So just like what we did previously, so 1101 in base 2 is equals to 1 times 2 plus 1 times 2 plus 0 times 2 plus 1 times 2. So the powers will have 0 1 2 3. So this is 1 times 8 plus 1 times 4 plus 0 times 2 plus 1 times 1. 8 plus 4 plus 0 plus 1, we have 13. So 1101 in binary or in base 2, the equivalent of it is 13 in base 10. So we need to convert this 13 now to the base we want, which is base 5. So it's like doing long division. So let's divide this. Now we have 13 here, we're going to divide by 5. So 5 here will give us 2. Now we write down the remainder here. So 5 into 2 cannot go, so it's 0. Remainder 2. So 5 into 0 cannot go, so we'll bring down the 2. So we have the arrow going up. So 1101 base 2 will give us what? The equivalent of 23. base 5. So let's look at some examples quickly. We have convert the following base 10 to binary. So they're in base 10 already. So for us to convert it to binary, we just divide. We have 9 here. So we divide by 2 since it's binary. Now 2 here. 2 in 9 is 4. Remainder 1. So we go again. 2 into 2 into 4 is 2. Remainder 0. So go again. 2 here, 1, remainder 0. We go again. 2 into 1 cannot go. Zero. We'll bring down the 1. So our arrow goes up like this. So 9 in base 10 to binary gives us 1 0 0 1. Of course, it's in base 2. So let's go at the second example quickly. We have 17. We divide again. So we have 2. Here we go 8 times remainder 1. We have 2 here, 4. Remainder 0. We have 2 here, 2. Remainder 0 again. So we have 2 again. Into 2 is 1, still remainder 0. Then we go again with 2. Here cannot go. 0, bring down the 1. So now 17 in base 10, the equivalent of it binary is going to be 1 0 0 0 1 base 2. So let's look at the addition and subtraction of binary quickly. Now we have some rules for the addition. Let's take note of this. Very, very important. Now addition result for binary numbers. We have 1 plus 0 is 1. 1 plus 1 is 10. That's in base 2 or binary. 1 plus 1 is 11 in binary. Now same key for subtraction also. We have 1 minus 0. Binary is 1. 10 minus 1 is 1. And 11 minus 1 is 10. So we have some few examples here. Calculate using binary numbers. We have the first one as 111 plus 100. So from here we do simple addition in base 2. Now since binary is in base 2, 1 plus 0 is 1, 1 plus 0 is 1, and 1 plus 1 is 10 in binary. So that does it. Number 2, we have 1 plus 0 again is 1, 0 plus 1 is 1, and 1 plus 1 again is 10. So we'll go to the next one. We have 1 plus 1 is 10. We write down 0, carry 1. So 1 plus 1 again is 10. Plus the other one is 11. We write 1, carry 1. So 1 plus 1 again is 10. Plus 1, 11. We write 1, carry 1. So 1 plus 0 now. Plus the 1 we carry, making it 10. So we have for subtraction, we have some few examples also. We have 111 minus 101. So 1 minus 1 is 0, 1 minus 0 is 1, and 1 minus 1 is 0. If you like, you can put down the 0, but I think it's not necessary. So here again we have 0 minus 1. So 0 minus 1 is not possible, so we need to borrow 1 from here and add it to this one. Or borrow 1 here and add it here, it becomes a base. Whenever you're borrowing, it becomes a base. So we have 2 minus 1 here, which is 1, and then here we're left with 0. So we'll borrow 1 from here again and add it to this 0, it becomes a base again. That's 2 minus 1, so we have 1. So that's why we have it as what? 11. So let's go to the next one quickly. So here we have 1 1 0 0 minus 1 0 1. Here again we're going to borrow 1 here, bring it here, and bring it here. So that becomes a base. 2 minus 1 is 1. We borrow 1 here again, add it here. 2 minus 1 is 1 again. Then we borrow 1 again, add it here. It becomes a base. That's 2 minus 1 again is 1. So that does it. Hope we get that. So we have some few examples here. So we have 1 plus 1. We want to add the following binary numbers now. 1 plus 1 is 10. So we're going to write, okay, 1 here. 1 1 plus 1 1. So 1 plus 1 now is 10. We are right 0 carry 1. 1 plus 1 is 10 plus this 1. We have 11. So second question we have 1 0 1 1 plus 1 1 0 1, all in binary, base 2. So we have, we're adding, don't forget that. So we have 1 plus 1 is 10. So write 0 carry 1. Now 1 plus 0, 0 plus 1 is 10 again. We have 0 carry 1. 1 plus 1 again is 10. We write 0 carry 1. So we have 1 plus 1 is 10 plus 1 is 11. Hope we get that. Dialing base 2 2 2 2 2 and 2. So let's look at some few examples under subtraction. We have the first one here is 1 1 minus 1 0. Now 1 minus 0 is 1, and 1 minus 1 is 0, base 2. So that's all for that. Now the second one we have 1 1 1 and 1 0 1, base 2 also. So 1 minus 1 is 0. 1 minus 0, we have it as 1, and 1 minus 1 is 0 again, in base 2. So let's look at the system of multiplication in binary. So the binary multiplication obeys the 4 basic rules. We have the first one, 0 times 0, we have 0. 0 times 1 is 0, 1 times 0, 0, and 1 times 1 is 1. So let's look at this example quickly. We have 101 times 1 1. We have 1 times 1 is 1. 1 times 0, we have 0. 1 times 1, we have 1. So pick this one again. 1 times 1, we have this one here. 1 times 0, we have 0. Then 1 times 1, we have 1. So we now do the normal addition. So this 1 is going to drop down here. So we have 1. 0 plus 1 is 1. 1 plus 0 is 1. And 1 plus 0 is still 1. So let's go to the next one quickly. We have 1 0 1 0 times 1 0 1. 1 times 0 we have 0, 1 times 1 is 1, 1 times 0 we have 0, 1 times 1 we have 1 again. Then we'll go with this 0. Pick 0 times 0, we have 0. In fact, 0 multiplying all these numbers here, we're going to have zeros all through. So we'll pick this one again. Times 0, we have 0. Times 1 is 1. Times 0, 0 times 1 is 1 again. So we now do the usual addition. So we add, bring down the 0. 1 plus 0 is 1. 0 plus 0 plus 0, 0. 1 plus 0 plus 1 is 10. 1 plus 0 plus 1 is 10. So we write down 0, carry 1. So 0 plus 0 is 0 plus 1 is 1. Then we drop down our 1. So I think we've come to the end of today's class on binary system. So join me next week as we take the next topic. In case you have any question, there's a column below for comments, and you can always tell us on how we can improve on this series. So thank you very much and have a nice day.